This is an Excel sheet for the design of the waste stabilization pond for the domestic wastewater treatment. You just need to enter the average wastewater flow into this Excel sheet, like I'm entering 10 million liters of sewage per day. Then you will get the design of anaerobic pond, the drawing of the anaerobic pond, facultative pond, and the drawing of the facultative pond, and also you will get the design of the maturation pond also and its drawing. You just need to enter the average wastewater flow for easy design and drawing. However, you can also enter other variables as well to get a more customized design. So I have linked an article of the sewage treatment plant for a waste stabilization pond in the description of this video and the first comment as well. This is a case of Birgun's metropolitan city in Nepal, which consists of two anaerobic ponds and two facultative ponds, in which the waste enters into the anaerobic pond and goes into facultative pond, and the BOD reduced effluent wastewater comes out into the effluent stream. So this sewage treatment plant in Birgun's has waste stabilization pond system of sewage treatment. The waste stabilization pond has various advantages and also some disadvantages. The waste stabilization pond is a series of ponds, and the first pond is an anaerobic pond which works by the process of anaerobic digestion. The facultative pond, in which oxygen is at top and no oxygen is bottom, by the facultative bacteria. And the third is the aerobic pond or the maturation pond, which do the reduction of the pathogen by the aerobic bacteria. And the waste stabilization pond can be made in several configurations in different forms. In first, we can see there is only facultative pond. In second, in which there is anaerobic pond and the facultative pond, like the case of this, there is two anaerobic pond and two facultative pond. And also it can be facultative pond and a series of maturation pond, or anaerobic pond, facultative pond, and a series of maturation pond. Generally, the depth of the anaerobic pond is kept as 2 to 5 meters and the detention time from 1 to 7 days, and the facultative pond it is 1 to 2.5 meters of depth and 5 to 30 days of detention time. And for maturation pond it is 0.5 to 1.5 meters, and detention time varies, which ranges from greater than 3 days to the detention time lesser than the facultative pond detention time. I have linked a design sheet in which you can directly enter the value and get the design output. You can also use it to roughly estimate the area required or how large the pond is required. So if I enter the average flow of wastewater to be 10, then the design itself changes and you get the design of the anaerobic pond, the facultative pond, and the maturation pond. So this is the same Excel sheet. So if I enter the average wastewater flow or the sewage flow as 10 million liters per day, then it converts into meter cube per day, and the initial BOD5 if I input as 300 milligrams per liter, this is the input. And for the design of anaerobic pond, the number of pond I have taken is 2, and the mean monthly temperature in the coolest month I have taken as 21.5 degrees centigrade, and the volumetric loading I have taken based on the formula of 20T. Lambda is volumetric loading equals to 20 temperature minus 100. It gives the volumetric loading as the anaerobic pond is designed based on the volumetric loading, whereas the facultative pond is based on the surface loading rate. It means that the anaerobic pond needs volumetric loading rate so that it comes between 100 and 400 grams per meter cube per day. The lesser value generally ranges from 100, as aerobic condition needs to be maintained, and it generally does not exceed 400 grams per meter cube per day, as there will be a problem of order if it exceeds that. And you get the volume of the anaerobic pond as Va equals to Liq by lambda A. The detention time is calculated automatically. So the volume of the anaerobic pond came out to 5,000 meter cube. The depth of the anaerobic pond ranges from 2 to 5 meters, so I have taken a depth of 4.5 meters. The free body is calculated and the total depth of the pond is 5 meters. So the volume of the anaerobic pond is 5555.56 meter cube and the surface area is 1111.11, and the BOD removal efficiency is which I've taken is 50%. So this is the formula that I've used. For 10 to 20 degrees centigrade, the volumetric loading is 20 T minus 100. I've taken the BOD removal as 50%. So you get the design of the rectangular anaerobic pond, and also you will get the design of the trapezoidal anaerobic pond. You also get the section, rectangular section and a trapezoidal section. The dimension is top dimension, the bottom dimension, and the total depth of the pond, and also the number of the pond, which I have entered as 2. So this is the drawing of the anaerobic pond section in lengthwise direction and in widthwise direction, lengthwise and breadthwise. And for the facultative pond, I have entered 2 number of pond to be required, and the BOD input to the facultative pond is 150, and the BOD removal in the facultative pond I have taken as 80%, which is also given from this manual from Duncan Mara. It is generally 70 to 80%, and I have taken as 80%. So the facultative pond is based on the surface loading rate, which is given by formula based on latitude, based on temperature. So based on the latitude for Nepal in Birgans, the surface loading came out to be 161.29 kg per hectare per day from this formula, and based on the temperature which is given by this formula, it is calculated to be 281.69 kg per hectare per day. And also there is a third equation which is also based on temperature, which is given by Duncan Mara, which gives 20 T minus 120, which gives a surface loading rate 310 kg per hectare per day. And we take the larger of both the area based on latitude and temperature, which means that the area which have a lesser surface loading rate is the required area for the facultative pond. So automatically by the formula, the surface loading rate is taken as 161.29 and the area of the facultative pond is taken as 46,500 square meters. It's taken automatically, and the hydraulic retention time for it is 14.28 days. The freeboard and the depth, the total depth and the volume of the total volume of the pond came out to 83,235 cubic meter. And for the facultative pond, if rectangular, this is the required dimensions, and for the facultative pond, if it is trapezoidal, it is these values, and the dimension for the facultative pond as top is this, and for the bottom depth and the number of ponds, and the drawing is drawn automatically with the given values. And for the maturation pond, after the 80% reduction of BOD, the BOD to be treated is 30 milligrams per liter. And for the maturation pond, after the BOD reduction of 80%, the influent BOD to maturation pond came out to be 30 milligrams per liter. The SRT for anaerobic pond was 1 day, and the SRT for facultative pond was 14.28 days. Mean monthly temperature was 21.5. The KT value is calculated, and the depth of the maturation pond is 1 meter, which is taken. The influent number of coliform from facultative pond is assumed at 10 to the power 6 per 100 ml, and output effluent as 1000 nos of fecal coliform per 100 ml. So from this formula we are getting the SRT of 1 day for 1 pond. So as it is lesser than 3 days, it is ignored. For 2, 3, 4 trials also it is getting lesser and lesser. So the number of maturation pond is taken as 1, and the minimum days that is required is taken as 3. It should also not exceed 14.28 days, so it ranges from 3 days to the detention time of facultative pond. So in this you get the 1 number of maturation pond and the section of the maturation pond and the drawing of the rectangular and the dimension of the rectangular maturation pond if it is used, or the trapezoidal maturation pond if it is used, is given from this sheet. So the top dimensions, bottom dimensions, Depth of pond and number of ponds are given for the trapezoidal section, and the drawing is also calculated. There is also one way to do a very rough estimate, which is given by this manual. So you just enter if it is 1 lakh people, the total area required in hectare for the waste stabilization pond, for the anaerobic pond, total area required for anaerobic pond, and for the facultative pond only the total area that will be required to construct a waste stabilization pond for the treatment of domestic wastewater. You can also be creative and can bypass the anaerobic pond, or you can also bypass the facultative pond or the maturation pond, and you can customize in any way that you require for your specific site condition.